Okay, let's unpack this. Welcome to a deep dive where, honestly, we're looking at ideas that can challenge almost everything you think about writing software.
Right. We're drawing heavily on some really forward-thinking perspectives from Alon Fliess today.
Yeah, and his work paints this picture of a future where AI isn't just, helping us write code faster. It might fundamentally change what code is, maybe even make it disappear in the way we know it.
Exactly. It's not just about assistance. It's about transformation.
So our mission today is really to explore some of the most, let's say, extreme possibilities Alon puts forward for AI and software development, and try to figure out what these potentially huge shifts could mean for you.
And it's a spectrum, right?
Yeah.
Some ideas feel closer, others are, well, truly radical.
Definitely. Think of this as maybe a shortcut to grasping some pretty mind-bending future scenarios. We'll hit the key points, enough for those aha moments, hopefully without getting too bogged down in the technical weeds.
Good plan. Because some of this gets complex fast.
Right. Like we're talking AI maybe working way below the level of Python or C#, potentially making languages like that.
Okay.
Well, maybe obsolete.
That's one of the big ones. Yeah.
And then there's this really revolutionary idea. Shipping prompts or ideas instead of actual compiled programs. Software with essentially no traditional code generated on the fly by AI based on what you want.
It's a huge leap from the AI coding assistance we see now. Alon's perspective suggests AI becomes the core engine, not just a tool, shifting from human-written instructions to AI systems driven by human goals.
It's a total reimagining of the digital building blocks we've used for, what, decades?
Pretty much. It's a fundamental rethink.
Okay, so that's what makes this so compelling. It's not just tweaking things. It's potentially a whole new paradigm. Let's start at the bottom then, this idea of AI bypassing high-level languages. What does that actually look like? What kind of code is the AI even writing?
Well, it implies the AI is generating instructions much, much closer to the hardware. Think assembler or even lower level like opcodes, maybe even microcode.
Microcode. That's like the really deep instructions controlling the CPU circuits themselves, right?
Exactly. Stuff humans rarely touch directly these days. You see hints of this now, maybe AI optimizing tiny bits of assembly. But the radical idea here is AI generating an entire application that way.
So instead of me writing Python, which then gets compiled down through various stages to machine code, the AI just writes the machine code straight out.
Pretty much, yeah. Or something very close to it. Imagine describing the logic you want, the behavior. The AI then translates that directly into the processor's native language.
Wow.
And it's hyper-optimized for the specific hardware it's running on, whether that's a regular CPU, a GPU for graphics, or even an FPGA.
An FPGA.
Yeah.
That's a field programmable gate array, like a blank chip you can configure with logic.
Precisely. It's like digital clay you can sculpt.
Oh, yeah.
So the AI isn't just writing software for existing hardware. It could potentially be tailoring the code and the hardware definition together.
Okay, hold on. Tailoring the software and the hardware.
Potentially, yes. That level of direct hardware interaction is, well, incredibly powerful for performance, squeezing every last bit of efficiency out of the silicon.
That sounds unbelievably complex for a person to do for a whole application.
For a human, yes, prohibitively so in most cases. But for an advanced AI, maybe not. It just shifts the complexity. The human provides the high-level goal, the what, and the AI handles the incredibly intricate how right down to the metal.
Okay, so the human focuses on the goal. AI handles the translation.
Right. And this approach, this direct generation, it raises a really important question about something else we rely on constantly. Managed environments.
You mean like the .NET runtime?
Yeah.
Or the Java virtual machine, the things that, handle memory, security boundaries, threading.
Exactly those. They provide vital services like garbage collection, cleaning up memory, automatically managing concurrent tasks. They hide a lot of complexity, which is great. That's why we use them.
But they're general purpose.
Yeah.
Built to work okay for most things.
Yes. And a general-purpose tool is almost never as efficient as one perfectly tailored for a specific job.
Right.
So Alon's vision suggests that if an AI truly understands the specific needs, the unique patterns of your application, it could generate custom code to manage memory, threads, resources way more efficiently.
How so?
Well, for instance, why use a general garbage collector if the AI knows precisely when an object is no longer needed and can reclaim that memory instantly? No guesswork.
Ah. So potentially no more of those unpredictable pauses you sometimes get when the garbage collector kicks in.
Potentially. or at least much better managed. And this idea extends to everything: how the app talks to the file system, the network, other processes. The AI, seeing the whole picture, could orchestrate these interactions with a kind of foresight and optimization that's, well, it's currently out of reach for us.
That's a massive shift. Moving from these general runtimes we all used to bespoke AI-generated environments for each specific app.
It is. But it gets even more radical, right? You mentioned it earlier, this idea of shipping prompts, not compiled code. This is where that software with no code idea really starts to take shape.
Yeah, this one really dens the mind. Explain that again.
Okay, so instead of compiling your app into, say, an executable file or a library, and then distributing that static thing.
Or the thing you download and install.
Exactly.
Yeah.
Instead, you distribute something else entirely. A high-level description, a specification, a prompt detailing what the application is supposed to do.
So you ship the idea.
You ship the idea, precisely. Then, on the user's device, there's a powerful local AI, maybe call it a just-in-time AI compiler or runtime, and it takes your prompt, your idea, and generates the actual application code, including the whole user interface right there, right then.
Wait, the UI isn't pre-built. It's generated dynamically.
That's the concept. It's generated based on the prompt, sure, but also based on the user's immediate intent, where they are in the application flow, their context, what device they're using, screen size, maybe accessibility needs, preferences, and the hardware they have.
Okay.
The AI understands the goal from the prompt and uses all that real-time context to generate the next screen, the right feedback, the buttons, the functionality needed right at that moment.
Okay, that is pretty wild. So the same idea could show up as a touch UI on my phone.
Or a keyboard mouse interface on your desktop.
Or even a voice interface on a smart speaker, all generated from the same core prompt.
That's the vision, yeah. Think about the portability and the optimization. The AI could generate code perfectly suited to that specific device. And even crazier, as that local AI gets smarter over time, maybe through updates or learning, the application could essentially regenerate itself to get better.
Better how?
Improve performance, maybe add subtle features, refine the UI, all without the original developer sending out a traditional update package.
The app literally improves itself while you use it. That's how. Okay, but my mind immediately jumps to security and intellectual property. Alon touches on this too, right?
Absolutely. Critical questions.
If you're just shipping the idea, the prompt, how do you stop someone just copying your prompt and cloning your whole business? And how do you trust that AI running on the user's machine isn't compromised or doing something malicious when it generates the code?
Huge challenges. They'd need completely new solutions. Security shifts focus dramatically, doesn't it? Instead of securing static code, you're now worried about the integrity of the prompt itself and, crucially, the trustworthiness of that local AI environment.
Right.
Protecting the IP. Maybe it involves new kinds of encryption or obfuscation for the prompt, or maybe the value isn't even in the prompt or the generated code anymore. Maybe it's in proprietary data the app uses or network effects, things the AI can't just replicate from a prompt.
So the value moves. It's not the lines of code, it's something else.
Exactly. Which ties into another related idea: the potential disappearance of traditional libraries and packages.
You mean like NuGet, NPM, Maven, all those package managers we use to pull in reusable code?
Potentially, yeah. Instead of searching for, say, a third-party library to parse some data format or draw a chart, you'd just tell your AI system what you need, state the intent.
And the AI would just write the code for that function itself.
Yes. Generate it directly into your application, tailored perfectly for how you need to use it, fitting seamlessly with the rest of the AI-generated code.
So, maybe goodbye to dependency hell. No more fighting conflicting library versions. We're dealing with huge dependency trees.
That's the potential upside. You get lean, optimized code generated just for your specific need. Now, the flip side, the challenge, is obviously huge.
Right. You lose the benefit of code that's been tested by thousands, battled, hardened over years, security holes found and fixed.
Exactly. Trusting the AI to generate code that's correct, performs well, and is secure, especially for complex tasks. That becomes absolutely paramount. It seems likely, maybe especially at first, you'd see a hybrid approach. AI generates a lot of the application logic, but maybe it still relies on some core foundational components that are perhaps formally verified, proven correct.
Okay, formally verified. We should definitely come back to that.
Yeah.
But this whole thread, again, points to the idea that the basic unit of software is changing. We're not packaging code anymore. We're packaging ideas,
Yeah.
intent, maybe trusted AI models.
That seems to be the trajectory Alon is sketching out. And if the AI is handling all this low-level coding, managing dependencies, or generating replacements, what happens to the human developer? The role must change, right?
Drastically.
This sounds like where that super developer concept comes in. The person orchestrating the AI, not just typing code.
Precisely. The human role gets elevated significantly. You're not primarily banging out lines of code in an editor. You become more of a systems thinker, an architect, a product visionary, an AI conductor.
Conductor, I like that. Your key skill becomes articulating really complex business problems, user needs, system goals with enough clarity, enough precision that the AI can reliably translate them into working software.
So you're defining the what and the why, setting performance goals, reliability targets, the overall architecture.
Yeah.
And you let the AI handle the how down at the code level.
That's the idea. This role needs deep understanding of the problem space, yes, but also system design, and critically, how to communicate effectively with these powerful AI systems, how to guide them. The real value is in bridging that gap between human intent and AI execution, managing the whole system's health.
You mentioned site reliability engineers, SREs, earlier. People focused on keeping systems running reliably in production. Is that related?
I think it's very related. It's like combining the strategic view of an architect with the operational focus of an SRE. You're responsible for the system's overall health, its performance, security, correctness, but now you're achieving that by directing the AI generation process from the start.
So instead of fixing reliability problems after the code is written, you're defining reliability requirements for the AI to build to in the first place.
Exactly. Building it in, not bolting it on.
Okay, so if the AI is generating all this, what about testing? That's a massive part of development now. Does testing just go away?
Not go away, but transform. This is another area Alon points to for radical change. The focus shifts from finding bugs after the code is written to proving the code is correct as it's being generated.
Proving it. How?
The idea is the AI that generates the application code would simultaneously co-generate a formal mathematical proof that the code behaves exactly according to its specifications.
A mathematical proof. Like proving a theorem in math class, but for software.
That's a decent analogy, yeah. It's called formal verification, using mathematical logic to guarantee properties. Today, doing this by hand is incredibly hard, very time-consuming, usually only done for supercritical things like flight control software or parts of operating systems.
But AI could automate it.
That's the potential game changer, making provably correct software the standard, not the exception.
Provably correct. I mean, for critical systems, that's huge. No more subtle bugs, no zero-day exploits hiding in the logic.
That's the promise. And security thinking follows a similar path, moving beyond just finding vulnerabilities after the fact. Alon's vision includes proactive, generative security.
Generative security, what does that mean?
Okay, imagine one AI system whose job is to build the application. Let's call it the blue team AI.
Okay, the builder.
Right. Now imagine another AI running concurrently. Its job is to act like a sophisticated attacker, the red team AI. It constantly probes, attacks, and tries to find flaws in the code the blue team AI is generating.
So an AI building the software and another AI trying to break it simultaneously during development.
Exactly. The red team AI invents new attacks. The blue team AI instantly sees the vulnerability, understands the attack vector, and regenerates the code to patch it, to make it resilient before it's even deployed. The software is essentially born secure. It's pre-hardened against AI-level attacks because it was built and attacked at the same time.
That sounds like a constant, high-speed digital arms race.
Yeah.
But compressed entirely within the build process itself.
It's a fascinating concept, isn't it? Moving security from reaction to proactive generation. And this idea of continuous process, continuous generation, and verification that leads directly into another concept. Living software.
Living software.
Yeah.
Meaning no more versions, no V1, V2, V2.1 updates.
Potentially. The idea is software stops being a static product you ship in discrete versions. It becomes a continuously evolving entity.
How did it evolve?
It monitors itself in the real world, observes its own performance, maybe even watches how users interact with it, within privacy bounds, of course, and then it autonomously generates tests using those formal methods and adversarial checks, and deploys its own improvements.
So the software itself notices, hey, this database query is slow for some users, and then figures out how to fix it, tests the fix, and rolls it out, without a human developer scheduling a patch.
That's the core idea. Maybe it identifies a bottleneck, generates optimized code, runs a small A/B test deployment, analyzes the results, and if it works better, rolls it out fully, all automatically.
The whole software development lifecycle just kind of dissolves into this continuous autonomous loop.
Right, which completely changes what finished software even
That's
means.
never finished, just constantly adapting.
Always optimizing, always adapting.
Okay, so with all these huge potential changes, AI, writing low-level code, replacing runtimes, shipping prompts, no libraries, automated testing and security, this living software idea, what does this do to the economics,
Yeah.
a software industry, how we value tech companies?
Yeah, Alon's take on this is pretty stark, but it follows logically. If AI can churn out routine code faster, cheaper, and maybe better than humans, then the ability to just write standard code to translate basic requirements into functions, that skill becomes commoditized.
Meaning developer salaries for pure coding roles could stagnate or even decline.
It's a real possibility for roles that are just about implementation, but that super developer role we talked about,
The orchestrator, the architect, the AI conductor.
that role becomes incredibly valuable, commands a huge premium. Their value isn't in the lines of code typed, but in the ability to define, architect, and guide these complex AI-driven systems. The value moves way up the stack: abstract thinking, system design, strategic intent.
And for companies, if anyone can generate features quickly with AI, does having a big existing code base still matter as much?
Probably not nearly as much. Your proprietary code isn't the defensive mode it once was if a competitor can spin up similar functionality using AI relatively quickly.
So where does the company's value lie then?
It shifts. It lies in things AI can't easily replicate. Your unique proprietary data that's crucial fuel for the AI. Strong network effects around your product. Brand trust. And maybe most importantly, your business agility. How fast can you turn new market insights or ideas into functional, deployed software using these AI tools? That becomes the key advantage.
So speed and effectiveness in using AI to ideate and execute rather than the code artifact itself.
Precisely. You could see very lean, agile companies potentially disrupting huge incumbents simply because they're better and faster at leveraging AI to generate and evolve their software.
This paints a really powerful, almost startling picture of a no-code future, at least no code as we traditionally think of it. But the sources, Alon included, make a really crucial point too. Even in this world, some kind of precise logic definition is still vital. Why is that, if AI is generating UIs and stuff from prompts?
That's a key nuance because the dynamic UI, the screens, the buttons, that's just the surface. AI might be fantastic at generating that based on context, based on general intent, show me my recent orders. But the core of the application, the really complex stuff, like the intricate business rules, managing the application's internal state consistently, ensuring data integrity, especially when talking to other systems, handling complex security protocols, integrating services reliably. Think about it. Natural language prompts are great for expressing general goals, but they are often inherently ambiguous when you need absolute precision. How do you use just a prompt to specify, without any ambiguity, the exact complex calculation for pricing an airline ticket with all its taxes, fees, loyalty rules, exceptions?
Yeah, you can't just say make it fair or calculate the price. You need exact rules.
Exactly. Or how do you guarantee a financial transaction is atomic, meaning it either completes entirely, all steps succeed, or it fails completely and rolls back, leaving no partial changes? You can't leave that kind of critical logic open to interpretation by an AI based on a vague prompt.
You need something formal, something unambiguous for those critical parts.
Precisely. You need a formal way to define those core non-negotiable rules and contracts. The soul of the application, you might say, underneath that fluid AI-generated surface. This likely still requires a structured, formal language, maybe an evolution of what we call code today, but perhaps much more focused on declaratively defining what the rules are, rather than how to implement them step by step. A language optimized for specifying this critical business logic and system contracts for an AI to consume and adhere to strictly.
Okay, so no code might be true for the UI, for the boilerplate, for maybe a lot of the interaction logic. But the deep, critical business rules still need that rigorous formal definition. It's just maybe not C# or Python as we know them.
That seems like a very plausible outcome, balancing the power of AI generation with the need for absolute correctness in critical areas.
So reflecting on all this, we've really gone deep into a future, heavily inspired by Alon Fliess' thinking, where AI fundamentally reshapes software creation, moving way beyond just assisting coders.
Yeah, we've touched on AI potentially writing machine code directly, making our current languages and runtimes less relevant. We talked about shipping ideas, prompts instead of compiled binaries.
Right, leading to that no-code software concept where the app generates itself on the user's device. And transforming testing and security, moving from finding bugs to proving correctness, from patching holes to generative adversarial security built in.
And that mind-bending idea of living software constantly evolving itself, it's a lot.
It really is. And the core message from the source material seems to be that the value proposition is shifting dramatically. It's less about the lines of code you physically write.
And more about things like your unique data, your network effects, your overall business agility, and crucially, the human ability to have the vision to architect the system strategically and define intent with precision.
Your role, potentially, moves from code crafter to system orchestrator. That super developer we discussed, defining the vision, setting the goals, guiding the AI.
But even with this revolutionary no-code idea, especially for UIs generated from prompts, we have to remember that critical point. Complex systems still need unambiguous logic, state management, data integrity, core business rules.
Right. The surface might become fluid, generated on the fly, but the application's soul, its core contracts, likely still needs a formal, precise language, an evolution of code designed for this new world.
And this isn't pure fantasy, is it? We see the seeds of these trends now. AI code generation is improving incredibly fast. The real question for you listening is, how do you prepare? How do we adapt? What skills become paramount when the focus shifts from crafting code to conducting AI?
Definitely questions worth pondering.
And then maybe here's a final thought to leave you with. Building on that living software idea. If software is no longer a static thing we build, version, and ship, but it's this continuously evolving, self-improving service, what does finished even mean anymore?